Hey guys, today's flipped lesson is on 4.3, proving triangles congruent. We're going to introduce two specific methods for proving triangles congruent, SSS and SAS. Let's get started. So how much do we really need to know about two triangles to prove that they're congruent? That's the real question that we're trying to answer today. So in last night's lesson, you learned that if all 6 pairs of corresponding parts are congruent, then the triangles are congruent. So for example, if all 3 sets of sides are congruent, and if all 3 sets of angles are congruent, then we can conclude that the triangles are congruent. But do we really need to know all 6 pieces in order to make this conclusion? So in this lesson and the next, you're going to learn that you don't need all 6 of the pieces of information to prove that the triangles are congruent. For example, if all 3 pairs of corresponding sides are congruent, then this postulate, the SSS congruence postulate, guarantees that the triangles are congruent. Okay, so notice in this diagram, we have this set of sides, this set of sides, and this set of sides are congruent. Therefore, overall, the triangles are congruent. So instead of needing 6 things, we only had to conclude 3 things. Let's practice this idea. So we're going to prove that triangle PQW is congruent to triangle TSW. We're going to do this in a 2-column proof format. So we have our statements and we have our reasons. So here's my first statement. PQ is congruent to TS. Now notice that is just given information in the diagram. If you look at the diagram, that is given. Statement number 2, PW is congruent to WT. Again, this is another piece of given information. And then the last piece of given information is that QW is congruent to SW. Now that we have concluded that all 3 sets of sides are congruent, I'm going to make the statement that triangle PQW is congruent to triangle TSW, okay, by the side, side, side postulate. And technically it's a congruence postulate, so I'll attach that to the end. All right, now, there's also another way to prove triangles congruent outside of listing all 6 pieces. Okay, and that's by side angle side congruence postulate. So notice again, there's only 3 things that we have to conclude in order to prove the triangle's congruent. Now, the one thing that I do want to mention is that the order of this matters. The angle that's congruent has to be in between the congruent sides. So if you notice, Q is in between the congruent sides, T is in between the congruent sides. So it has to be the angle in between the congruent sides in order to use this postulate. If the angle weren't in between, then this would read as ASS. That should be a clear indication that you are not using the correct postulate. That's why the angle has to be included. Okay? All right. So let's play around with this idea. We're going to prove that these triangles are congruent. Let's set up our statements and our reasons column. Okay, the first statement I'm going to make is that BE is congruent to EC. And if you notice, that was just given by the marks in the picture. Okay, also, AE is congruent to DE. And again, that was given by the marks in the picture. Okay, next I'm going to make the conclusion that angle 1 is congruent to angle 2. Now, why do we know that? Well, we know that those are vertical angles, and vertical angles are congruent. So now notice 1 and 2 are in between the congruent sides. So I am now able to make my conclusion that triangle AEB is congruent to triangle DEC, and this is by the side angle side congruence postulate. All right, so that one challenging piece that you had to come up with on your own was the fact that vertical angles are congruent, which is not new to us, but we do need a little bit of practice with it. All right, let's try another situation. We're going to decide if there's enough information to prove those triangles congruent. So let's start with our statements and our reasons. Okay, let's make this first statement. I'm going to conclude that QP is congruent to PS, and that's just given by the tick marks. Next, I'm going to conclude that QR must be congruent to SR by the given tick marks. And here's the last piece I'm going to conclude. Right, PR of the left triangle is congruent to PR of the right triangle. And what allows us to say that something is congruent to itself? I always think about this thing looking at its reflection, reflexive property. All right, now we have 3 sets of sides that are congruent. So I think we are good to conclude that triangle PQR is congruent to triangle PSR by our side congruence postulate. All right, good work with that one. In this example, we have a guided proof, meaning the statements are filled in, they're guiding us along the way, but we need to back up those statements with valid reasons. So let's get started. Statement number 1, we'll take a look. That is just a given piece of information, given. Right, and notice, saying that DR is perpendicular to AG. Well, what does that mean? DR is perpendicular to AG. That means those lines intersect at a right angle. So notice in this next statement, they are concluding that those are right angles. That is just by definition of perpendicular lines. Right, if the lines are perpendicular, then those are right angles. Then going from 2 to 3, if those are right angles, then they are congruent. And we're going to back this up with the statement that all right angles are congruent. Right? And it makes sense. If they're all 90 degrees, then they're all going to be congruent. Next, we're concluding that RA is congruent to RG. Let's look at the picture. Oh, notice that is given information. RA is congruent to RG. That was given. All right. So far, we have proved a set of sides congruent and a set of angles congruent. Notice that would be a box on the left side. All right, last but not least, they're saying that DR of the left triangle is congruent to DR of the right triangle. That is reflexive property. And technically that's a POC, right? Because we're dealing with a congruent symbol, not an equal symbol. All right, now we're making the conclusion that those triangles must be congruent. Well, which postulate were we using? It looks like we're using side, angle, side. Notice that the right angle is in between the congruent sides. So SAS congruence postulate. All right, good work on that guided proof. Here's the last example in our video. It says, use the SSS congruence postulate to show that those triangles are indeed congruent. Well, keep in mind, If the distance is horizontal, or if the distance is vertical, then we can just count that distance. So for example, this has 3 blocks. That one has 3 blocks. This has 1, 2, 3, 4, 5 blocks. This one has 1, 2, 3, 4, 5 blocks. So guys, it looks like the only thing we're going to have to calculate are the diagonal distances. Okay, well, keep in mind, we have a formula that helps us calculate distances. It's the distance formula. Okay, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So let's break this up. I'm going to find the distance from B to C right here. And then on the other side, I'm going to find the distance from G to H. All right, well, let's do B to C first. We're going to use these coordinates. Maybe I say this is x1, y1. So that means that this would be x2, y2. So let's start plugging them in. x2 minus x1. Well, if you're subtracting a negative, it's going to become addition. And then, let me connect that 4. Good. Now, y2 minus y1 squared. All right, let's just begin simplifying. Negative 7 plus 4, that's going to be negative 3 squared. And then 0 minus 5, that's going to be negative 5 squared. Well, keep in mind, if you square something, you're really just multiplying it to itself. So negative 3 times negative 3 is 9. Negative 5 times negative 5 is 25. So it looks like this is going to be the square root of 34. All right, now let's see what happens on the other side. We'll let this one be the x1, y1, x2, y2, and let's get started. So x2 minus x1 squared plus y2 minus y1 squared. Well, this is going to give us negative 5 squared. That will give us negative 3 squared. Well, negative 5 times negative 5 is 25. Negative 3 times negative 3 is 9. So we're getting the square root of 34. So guys, this side is congruent to that side. There are 3 sets of sides congruent. So I do believe that triangle ABC is congruent to triangle FGH by SSS. That concludes your notes for today. Make sure you upload your notes to Shobi and then attempt the 4.3 practice problems so we can discuss them in class tomorrow. Thanks, guys.